Good evening, my dear students. Today's topic is carbonyl compounds. We have already studied 2 lectures of carbonyl compounds. Now this is the 3rd lecture, and in this 3rd lecture I start with aldol condensation reaction. So I continue the same aldol condensation reaction. Aldol is the name of product. In the product there are 2 functional groups. One is aldehyde and another is alcohol. So combinedly it is known as aldol reaction. So condition for the aldol reaction is like this. So first is the condition which can give aldol reaction. Carbonyl compounds in which sp3 alpha CHCD, or you can say enolizable hydrogen, are present. Then aldol reaction is possible. So very important condition is in which sp3 alpha CHCD or enolizable hydrogen are present. sp3, note it down, that is sp3. Now medium, or you can write reagent. Reagent both possible, either acidic medium or basic. So first in dilute phase, or second in acid. Dilute base you can take NaOH, KOH, aqueous Na2CO3, aqueous K2CO3. There are many types of base. So I write here some examples. Dilute NaOH, KOH, aqueous Na2CO3, K2CO3, etc. Now products. There are 2 different products in 2 different steps. So in the first step, the first product is known as aldol product. So aldol is beta hydroxy carbonyl. Aldol is the beta hydroxy carbonyl. It is represented as like this. With respect to aldehyde ketone, the first carbon is alpha and the second carbon is beta. So beta hydroxy carbonyl compound is the product and it is known as aldol product. Now the aldol condensation. Aldol condensation product is alpha beta unsaturated carbonyl. It is alpha beta unsaturated carbonyl, means a pi bond between the alpha and beta carbon. It is like this, alpha beta unsaturated carbonyl compound. So these are the important informations. Now next one is about the mechanism. So next is the mechanism. So there are total 3 steps. Step first, it is acid-base reaction with sp3 alpha CH. And in this step, a nucleophile is prepared, or you can write preparation of carbanionic nucleophile. Carbanionic nucleophile. Second step, Step 2, nucleophilic addition. Now step 3, that is dehydration. By E1CB mechanism in basic medium. So there are total 3 steps. Step 1, acid-base reaction. Step 2, nucleophilic addition. Step 3, E1CB, that is dehydration elimination reaction. Now I write the mechanism. Suppose I take CH3 CHO. In basic medium dilute base. So this carbon is alpha carbon and it is sp3 and hydrogen is also present. So in the first step, acid base reaction takes place and a carbanion is obtained. This carbanion is resonance stabilized. So this intermediate is resonance stabilized, that's why alpha hydrogen is slightly acidic because of this stability of conjugate base. It is known as enolate ion and this is known as carbanion. So this is the first step. Now in the second step, this nucleophile attack to the another molecule of carbonyl compound. So C double bond O gives nucleophilic addition. So this negative charge attack to the carbon and this step is nucleophilic addition. After nucleophilic addition, there is a product like this, O minus CH2 CHO. And it gains the water molecule, it gains the hydrogen molecule and converted into beta hydroxycarbonyl. This product is known as aldol. This product is aldol. So to prepare aldol, there are 2 steps. Step 1, acid-base reaction, preparation of nucleophile. Step 2, nucleophilic addition, preparation of a product. In the next step, if I increase the temperature, then dehydration takes place by E1CB mechanism. E1CB means acidic strength of the hydrogen must be little higher than the normal. So it is because of minus I minus M group of ketone or aldehyde. So E1CB takes place and after dehydration, alpha beta unsaturated carbonyl compound is obtained. So this is the condensation product. This product is the condensation product. Now trick is this, how to identify the reactant from the product. So we can identify by this. Please break the bond between alpha and beta carbon and return their molecules. So at alpha position return the hydrogen atom and beta position return the oxygen atom. So after adding the OH2, we again find the reactant CH3CHO, CH3CHO. These are the reactant. So it is a trick to identify the reactants. And in this case again you can hear also So return the hydrogen to the alpha carbon, then only we can get the initial reactant. So in this case, few important points are like this. First point, rate is directly proportional to 2 molecules of aldehydes and 1 molecule of base. So order of reaction is generally 3 because 2 aldehyde molecules are required and 2 aldehyde molecules and 1 molecule of base. So order of reaction is 3. Generally step 2 is RDS, but in some case, in some aldehydes, step 1 is RDS. So I repeat the whole mechanism. First, those carbonyl compounds which have sp3 alpha CH, then only aldol reaction is possible. Step 1, acid base reaction, nucleophile is obtained. Step 2, nucleophilic addition at the C double bond O. After addition we get the aldol. And step 3, that is the last step, and even CB. So H and OH are eliminated in this. So product is always conjugated pi sigma pi. Rate depends upon the 2 molecule of aldehyde and 1 molecule of base. So that's why order of reaction is 3. Generally step 2 is RDS, but in some aldehydes step 1 is also RDS step. Now we are taking few examples. Suppose A, self aldol reaction or intermolecular aldol reaction. Question number 1. Suppose I take this molecule. So alpha hydrogen is present and carbon is sp3. And dilute base, what is the product? So by the trick we can write directly. First I write the molecule completely after breaking the pi bond. So pi bond is broken. Now I write O and one free valency. Now nucleophile add to this carbon. So nucleophile is C minus at alpha carbon. So I add the alpha carbon with this and hydrogen at this. So this is the aldol product. By trick you can break the alpha and beta and verify the product. After heating, dehydration takes place. And alpha beta unsaturated product is again obtained. By the trick we can find the reactant also. So similarly we can write the product also. Question number 2, suppose I take the ketone. This reaction is possible for aldehyde as well as for ketone. Suppose OH minus is taken. Now write the first molecule as it is after broken the pi bond. So I write like this. Now add the nucleophile. So nucleophile was CH2 minus. Now add the hydrogen. So this product is known as aldol, and this is always beta hydroxy carbonyl compounds. After heating, dehydration takes place and alpha beta unsaturated carbonyl is obtained. Now question number 3. Suppose I take the PH CH2 CHO. Then think about the product. Alpha hydrogen is present. So first write the molecule as it is, PHCH2 CHO. Now add the nucleophile. So nucleophile is C minus, that is CHO and pH. After heating, pH CH2 CH double bond C pH CHO. The product. In all the products we can find the reactants very easily. Now in the fourth example, suppose I take the cyclic compound. This is cyclohexanone. So there are 4 alpha hydrogen atoms. So first I remove the alpha hydrogen. This is the nucleophile. Now in the second step, this nucleophile add to double bond O. After adding this, we can write like this. This product is aldol product alpha beta. This is beta hydroxy carbonyl compound. On heating by even CB mechanism, alpha beta unsaturated, that is alpha and beta unsaturated, or it is a conjugated system. This is the final product. So these are the examples of self-aldol reaction. If I take the 2 different carbonyl compounds, then the reaction is known as cross-aldol reaction. So in B, I take the cross-aldol. Major product in case of cross-aldol is obtained by nucleophilic addition to more reactive, less crowded carbonyl. Generally, cross product is major in this case, because it depends upon the reactivity of carbonyl compounds. So more reactive carbonyl give addition reaction faster than the less reactive carbonyl groups. That's why major product is obtained by the nucleophilic addition to the more reactive or less crowded carbonyl. Suppose I take the example like this. One is ketone plus another is aldehyde. So in general, aldehydes are more reactive than ketones. So nucleophilic addition at this carbon gives major product. So in basic medium, nucleophile prepare to more crowded side. This is the first step. Step 1, PHCO CH2 minus. Now this nucleophile add to the more reactive site, gives CS3 CHOH, nucleophile at carbon, hydrogen at oxygen, CH2CO pH. So this product is major product. In this case, a chiral atom is also produced. So if one chiral is produced, then products are enantiomers of each other, that is D plus L, racemic mixture. On heating this, water eliminates and one geometrical isomer is produced. So here is a geometrical isomer. So two products are obtained in this reaction. This is a cross aldol reaction. So in the cross aldol, we can again check the initial reactants by breaking the alpha and beta. So in second example, suppose CH2O plus CS3, or you can write PSCHO plus CS3CHO. So in this case, only CS3CHO have alpha hydrogen, but PSCHO does not. So in this situation, this condition fails because only one aldehyde or ketone have alpha H, another does not. So hydrogen cannot be removed from this aldehyde. So in this case, alpha hydrogen is removed from here. This is the first step. Now second step, nucleophilic addition to PSCHO. So this is PSCHOH, CH2CHO. This is the major product. Now after heating, water eliminates. Again there is a geometrical center, so two isomers are possible in this case. So this is known as cross aldol reaction. Now start with intramolecular aldol. It is possible in the dicarbonyl compound, possible in dicarbonyl compounds. Ring formation takes place. Preferable size of ring is 6, 5 than 7. This is the preferable size of ring. Again the condition is like this. Major product is obtained by nucleophilic addition to more reactive carbonyl. The other products are minor products. If possibilities are more than one, then this is the major product. Now check the question. Suppose this is the question. So there are three different alpha H in this case. With respect to C double bond O, here one type of alpha H, here another type of alpha H, and again with respect to this, here also one type of alpha H. So there are three types of alpha H. Just first count the ring. First check the by which carbon how much size of ring is obtained. So I count from this 1, 2, 3, 4, 5, 6, 7. If I react like this, then 7-membered ring is obtained. Suppose I count from here, so 5-member ring is obtained, or again 5-member ring is obtained from this. So 5 and 5 and 7. So which is the priority? 5-member. So we can use this or this H to prepare the major product. But this is the ketone, this is aldehyde. So aldehyde is more reactive. So this site is more reactive towards nucleophilic addition. That's why the first hydrogen removed from that site. So this is step 1, acid base reaction. So carbon ion is obtained, act as nucleophile. Now in the second step, this nucleophile add to the aldehyde group. This is the nucleophilic addition. I write the positions 1, 2, 3, 4 and 5. So 5-member ring is obtained like this. You can number the same ring again, 1, 2, 3, 4 and 5. So at the carbon number 1, COCH3 group is present. So carbon number 1, COCH3 group is present. At the carbon number 5, OH is obtained. So carbon number 5, OH is obtained. So this is again beta hydroxy carbonyl. With respect to carbonyl, first carbon alpha, second carbon beta. So it is again beta hydroxy carbonyl. This is known as aldol product formed by the intramolecular reaction. This is a nucleophilic addition in intramolecular reaction. On heating, water eliminates, alpha beta unsaturated carbonyl compound is obtained. You can check the reactant also or verify the reactant by breaking the alpha beta OH2. I repeat the whole procedure. Intramolecular aldol possible in dicarbonyl compounds only. Here is a dicarbonyl compound. Ring formation takes place because intramolecular ring formation takes place. Preference of the ring is 6, 5, 7. Major product is obtained by the nucleophilic addition to more reactive carbonyl. This is the more reactive carbonyl. So nucleophile add to this. So carbon ion form at this side. So I use this, and by nucleophilic addition, 5-member ring is formed, and this is the final product. Now in second example, CH3CO, CH2, 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 COH. There are again 3 types of alpha H, but this alpha H gives 6-membered ring. This gives 4-member ring only, 1, 2, 3, 4. This again 4-membered ring. So 4-membered ring is not preferable. That's why 6-member ring is obtained in this reaction. So nucleophilic addition takes place, 1, 2, 3, 4, 5, 6. So at second number, ketone is present. So 1, 2, 3, 4, 5, 6. At 6th number, OH group is present. So it is again beta hydroxy carbonyl. After heating, alpha beta unsaturated carbonyl is obtained. Third intramolecular type of reaction, like this. Suppose this is the compound in presence of OH minus. This is alpha. So first acid base reaction is done because all alpha hydrogens are same. In the second step, nucleophilic addition takes place. So it is converted into bicyclic compound, and compound is like this: 1, 2, 3, 4, 5. So 5-membered ring is formed, and the remaining is 7-membered ring. So this is the aldol product. Again, you can check alpha beta, beta hydroxycarbonyl. After removal of water molecule, then alpha beta unsaturated product is obtained. The next example, suppose this is the structure. So in basic medium, RKOH. Suppose I take this alpha H, so only 4-membered ring is formed. Suppose I take this, so 6-membered ring is formed. So step 1 is this. Now step 2 is this. So I write 2 steps simultaneously. So 6-membered ring is formed, and after heating, this is obtained. In basic medium, this molecule tautomerize and converted into aromatic compound. So this is the final major product. So aldol reaction is possible with self, cross, intramolecular. Now some other examples. First example, CH3NO2 in basic medium on reaction with, suppose, formaldehyde. This alpha H is removed because it is more acidic than the carbonyl compound. So nucleophile is obtained, and this nucleophile add to the carbon. So CH2OH, CH2NO2 is obtained as a nitroaldol, and on heating, dehydrations take place and alpha beta unsaturated compound is obtained. So this is important reaction, important example for the exam point of view. Now the similar example is, suppose I take CS3CN. This is again acidic. On reaction with again formaldehyde, we get the CH2OH, CH2CN. On heating, acrylonitrile is obtained. This is a useful compound used to prepare the polyacrylonitrile polymer, Orlon polymer, that is polyacrylonitrile. Next example, KOH, formaldehyde. So this hydrogen is again acidic. So react and remove the alpha H, and we can get CH2, CH2OH, NO2. This is also a type of aldol reaction. Now another very important reaction is suppose I take CS3CHO plus formaldehyde. Formaldehyde is taken in excess amount in presence of base. So there are 3 alpha H. So first I remove the first alpha H, then nucleophilic addition. So CH2, CHO, first CH2OH is obtained by nucleophilic addition of formaldehyde. Now I repeat this OH minus CH2 because we have excess amount of CH2. Then again second alpha H is removed. Then second time addition takes place. One alpha H is again present. So I repeat the same. Remove this alpha H and add to this. Then 3 moles of CH2OH are present on this carbon. So total 3 times aldol reaction takes place. Suppose this is the first aldol reaction, this is second aldol reaction, this is third aldol reaction. Now alpha H is finished or absent, but formaldehyde is again present in basic medium. Now Cannizzaro reaction takes place when the both aldehydes does not have or do not have alpha H, then Cannizzaro reaction takes place. So the fourth step, Cannizzaro reaction. In Cannizzaro reaction, smaller aldehydes converts into acid and the larger convert into alcohol. This is a redox reaction. This molecule is known as pentaerythritol and it can be written as like this: 4 CH2OH on 1 carbon. Name is pentaerythritol. This is a very important example, and pentaerythritol is used to make a polymer. Make a polymer named PTEN. Now this is the detailed discussion of aldol reaction. Now I continue with the next type of reaction. This is Claisen-Ester condensation. The next title is Claisen-Ester condensation. Ester word is in this name. So it is a reaction of ester. Reaction of ester which has sp3 alpha CH in basic medium, in a strong basic medium. Base is, for example, RO minus base is taken. Major product for this reaction is beta keto ester is the product. This is the major product obtained by this reaction. In this previous reaction, There are 3 times of aldol and 1 time Cannizzaro reaction. Now, Claisen-Aster condensation. It is a reaction of ester which have sp3 alpha H in a strong basic medium. So, mechanism is very much similar to the aldol reaction. Product is beta keto ester. So, I write the mechanism. Please look at. I take the ester CH3 COOET. In basic medium, suppose ETO minus is taken. So, alpha H is removed. So, first reaction is same acid base reaction. Nucleophile is prepared. Now, the next is substitution, because esters gives SN to TH reaction with nucleophiles. So, on reaction with nucleophile, substitution takes place. So, in this case alpha and beta. So, it is a beta keto ester. I repeat the mechanism. First, alpha H is removed, nucleophile is prepared. Now, this nucleophile attach to the another molecule of ester, and ester में leaving group है, so that's why OET leave from this molecule, and the final product is alpha beta. So, beta carbonyl ester, beta keto ester. Now, for practice, I write few questions. Suppose first, suppose this is a question, pH CH2 COET in presence of MeONA. This is strong base. So, alpha H is removed. pH CH COET. Now, in reaction with the second molecule, substitution takes place. The final product is like this. This is again beta keto ester. If I extend the mechanism, extend the reaction, then after hydrolysis, ester hydrolyzes in acidic or basic medium both. So, after hydrolysis of ester, pH CH2 CO CH COOH. This is beta keto acid. Beta keto acid on heating, alpha and beta, beta keto acid on heating decarboxylate very easily through cyclic transition state. So, ketone is obtained. Finally, ketone is obtained because acid removes through cyclic TS. Now, in the next question, suppose I take the ester like this. This is a diester, and both alpha hydrogen are same. So, in basic medium, suppose this alpha H is removed, then the 5-member ring is formed 1, 2, 3, 4, 5, and OPH is removed as a leaving group. So, cyclization takes place. Cyclization is possible first carbon CO OPH, and at this carbon ketone is present. So it is again beta ketoester. So this is the product. This is intramolecular Claisen ester condensation. So in the Claisen ester condensation, we remove leaving group from one molecule and alpha H from the another molecule. This is the procedure. Now the next reaction is Perkin reaction. This is again very important reaction, examination point of view. It was asked in the board as well as in the many competition exams repeatedly. So next reaction is Perkin reaction. Reactants are aromatic aldehydes which do not have alpha H plus anhydride plus acid salt of the same anhydride. Condition is prolonged heating at the long period of time at approx 140 degree centigrade. This is the condition. Now very important product is cinnamic acid or its derivative. So there are three important informations in Perkin reaction. First is aromatic aldehydes are taken in presence of anhydride with acid salt. The same acid salt is used. Prolonged heating is required. Cinnamic acid is the main major product. So reaction is like this. I write PHCHO with suppose acetic anhydride. In presence of acetic acid salt at heating. So this is aromatic aldehyde, this is anhydride. In case of anhydride, this is the alpha carbon. So alpha H must be present. So this alpha H is removed from here. But overall I write like this. H2CH. This is the alpha. So remove the water molecule from alpha H and oxygen of carbonyl. Then it has a leaving group. So again break the leaving group and add the same water molecule in this reaction. So I repeat the procedure. Aromatic aldehydes plus anhydride in presence of acid salt. So acid salt remove the alpha H, then it attacks on the carbonyl carbon and OH is formed. Then this OH and H is removed from the reaction. That's why this water molecule is again used to hydrolyze the anhydride, because anhydride give hydrolysis reaction in both medium, either in acidic or in basic medium. So final product is like this. PHCH comes from the aromatic aldehyde, then CHCOOH comes from the anhydride part. This is from anhydride and this is from aldehyde, and this is combinedly known as, this compound is known as cinnamic acid. This is the product. Byproduct is acetic acid. This is known as byproduct. So acetic acid is the byproduct and cinnamic acid is the major product. So I take the similar examples. Suppose question number 1. Suppose I take PSCHO plus CS3, CH2, CO, OCO, C2H5 in presence of C2H5, COONA at strong heating. So in this anhydride, the first carbon is alpha, second carbon is beta. So hydrogen removed from the alpha. So this is the removal and breaking of the bond OH and H. You can write the product. So major product of this reaction is PH, CH double bond C, CS3, C double bond. It's a major. So this is a derivative of cinnamic acid because cinnamic acid is PSCH double bond C double OH. So it is again PSCH double bond C double OH, but one methyl group is in the side chain. So it is a derivative of cinnamic acid. So if anhydride changes, then number of carbon also changes in the products. Now in the next question, this is important question. CHO and OH group is present. Suppose I take the acetic anhydride in presence of sodium acetate. So the same cinnamic acid is obtained. CH double bond CH, C double O H, and this is the OH. Alcohol and acid are present in the same molecule. Then after acidification and heating, esterification takes place. So after esterification, CH double bond CH, C double bond O, this molecule is obtained. The next example, suppose furane is taken, furane with aldehyde, furyl, with AC2O, ACONA, and the same reaction repeats with this molecule, and this is the major product. So this reaction is known as Perkin reaction. If two aromatic aldehydes are there, then 2 times this reactions takes place. Now another question is like this. Find the total products of cross aldol reaction between CH3 CHO and CS3 CH2 CHO. There are 2 different aldehydes. So find the total cross products. There is alpha hydrogen in both the case. So total 4 products are possible. One is self with the acetaldehyde, another self with propanaldehyde. 2 are cross from acetaldehyde to propane or propanaldehyde to acetaldehyde. So I write the total 4 products. This is the NCERT question. CS3 CHO plus CS3 CH2 CHO in basic medium. So first I write the self aldol CS3 CHOH CH2 CHO, CS3 CH2 CHOH CH CS3 CHO. These are the self aldol. Now the cross aldol. Cross aldol means first part of this, second part of this. Again second part of this, first part of this. So there are 2 cross products. So CS3 CHOH CHO CH3, CH2. So 2 cross and 2 self. So total 4 structure isomers are possible. These are the self, these are the cross. And this cross product is major, because more reactive aldehyde gives major product. There are total number of isomers including stereo. So answers are like this. Total aldol structure wise 4. Total aldol with stereo is 12. 1 chiral total products 2. 2 chiral total products 2 की power 2, that is 4. 2 chiral 2 की power 2, that is 4. Again 1 chiral, so total product 2. So total products 12. Now condensation product, total condensation product. Including stereo. So one double bond is formed in each case. So all gives geometrical isomers. So total 8. Cis trans, cis trans, cis trans in all the compounds. So that is the today's lecture. So I repeat the complete lecture. I started with carbonyl compounds, lecture number 3. So first reaction was aldol reaction. Condition: those carbonyl can give aldol which have sp3 alpha CH or CD bond, that is enolizable hydrogen. Then only aldol reaction is possible in both medium, either in acidic or in basic medium. The next one, aldol reaction is possible by self aldol, cross aldol, intramolecular aldol. But in case of intramolecular aldol, ring size preferable 6, then 5, then 7. 4 and 8 are generally avoidable. Now next reaction was Claisen ester condensation. It is a reaction of esters having sp3 alpha H in the strong basic medium. Aldol reaction is possible in the weak acidic weak basic medium, but Claisen ester condensation is possible only in strong basic medium. So final product was beta keto ester. But after hydrolysis of beta keto ester, we get the beta keto acid, and beta keto acid decarboxylate on heating. So final product was ketone. Now the last reaction was Perkin reaction. It is very important, asked in many competitive exams as well as in board. So Perkin reaction is possible with aromatic aldehyde plus anhydride plus salt of acid. It gives cinnamic acid is a major product, or if anhydride changes, then product is the part of cinnamic acid or a derivative of cinnamic acid. So thank you.